All right. If I could have everyone's attention, we'll start on our big topic today of empirical and molecular formulas. What's a molecular formula? Molecules. How we write molecules, how we write compounds are molecular formulas. You guys know those things already. You've written plenty of that one. What's in your project? Oh man. Oh well, thank you for letting me know that. I wouldn't have even noticed. I'll put it right on here on my tie. See if it stays there better. So it's not so you can hear me. It's so that my recording of this actually, doesn't sound like it's digital. Like the smartboard laptops do a very poor job with the microphones. So I'm using this thing. But empirical formulas, you've probably, and I'm assuming this, you've probably never heard of an empirical formula before, right? So it's the reverse. We're going to use some math today. It's going to be the reverse of percent composition. So percent composition, we were trying to figure out what percentage of a molecule or a compound was a certain element. Now we're going to give you a percentage of a compound. So we might give you CO2. And we might be like, hey, 80% of CO2 is carbon. What is the empirical formula for CO2 or for carbon CO2, carbon dioxide? So we're going to use math to figure that out. So we have 5 steps. 5 steps you're going to follow when you're doing these empirical formulas. If you follow these 5 steps, you will be successful with empirical formulas. So I would make sure of anything you write down today, you write down these 5 steps. Jared, you got a pencil? Noah, do you got a pencil? Write down these 5 steps. So step 1, if I could speak, we will give you a percentage, and you need to change that percentage to grams for each element. So in most cases, we will assume that we have 100 grams of any compound. So if we have 55% oxygen, what am I going to change 55% oxygen to if we assume we have 100 grams? 55 grams. I assume I have 100 grams unless told otherwise. Sometimes we might tell you that we have 170 grams. We'll talk about those later, but in general, we assume we have 100 grams of a compound. It just makes our math easier. Once we have our grams, we are going to convert to moles of our element. You guys should be able to do this by now. Really easy math at this point. You're going to take whatever mass you have, 55 grams of carbon, you're going to divide by the molar mass and figure out how many moles of carbon you have. Once you have your moles for each of your elements in your compound, you're going to divide by the lowest number of moles out of all of your elements. So if I have one element that has 5.1 moles and another element that has 2.3 moles, 2.3 is my lower of the two, my lowest number of moles that I have. I'm going to divide all of my other amounts of moles by 2.3. Then you need to make whole numbers of moles by multiplication. So there's going to be times where you'll get a number out like 1.5. Can we plug 1.5 into a molecular formula? Can we have 1.5 of an element? No, you can't have half an atom. It's not going to happen. If you do, you might have just created an atomic bomb. Splitting atoms makes explosions. Don't split atoms. We release a lot of energy. So we can't have 1.5. So we have to multiply 1.5 by a number to make it a whole number. So what would we multiply 1.5 by to get a whole number? 2. If I take 1.5 and I multiply by 2, I'm going to get 3. I'm set. I'm ready to go. And then my last step, these numbers are the subscripts in the formula. So in step 4, whatever numbers you get after multiplying, those become your subscripts in your molecular or your empirical formula. Hi, Ms. Pollack.
This is how I took attendance today.
Sweet.
So if they just want
I think what we should do, and we can talk about this later, we could just mark everybody, or start by marking everybody like absent, not press save, just or something, and then the people in your class you mark present, and then the people in my class we mark present, so we're not running back. But I don't know. We can figure something. We can figure something out.
That would throw parents into a conundrum.
Yeah, but
Kara's not in class.
yeah, we'll figure it out. Okay. We'll talk about it. So here's a question. This is a very common question you will see when we give you one of these. Determine the formula for the compound that consists of 42.12% carbon, 6.48% hydrogen, and 51.4% oxygen. What is the molar mass of the compound? Right now, just by looking at this question, can I figure out what the molar mass of my compound is? No, why? So you don't have the numbers, you don't have the amount of oxygen, you don't have the amount of carbon you have, you don't have your molecular formula. You can't find the molar mass. So we have to find what the molecular formula is for this question. So let's move. So I got a blank slide somewhere. Let's see. We'll just do it in the spaces. So determine the formula for the compound that consists. So like I said before, we're going to give you percentages. Rule 1 says we have to convert our percentages to grams. So I'm going to do that. I'm going to convert my percentage to grams. So I have 42.12% of carbon converts to 42.12 grams of carbon. So I'm going to do that for each of my elements that I have. So hydrogen, I'm going to have 6.48 grams of hydrogen. And oxygen, I'm going to have 51.4 grams of oxygen. Okay? With me so far. So that takes care of step 1. Now, step 2 says we got to convert grams to moles. So I'm going to set up my parentheses. I should end up in moles of oxygen. What's my molar mass of oxygen? If you look at your periodic table, it should be 15.99. 1 mole on top, that's our molar mass of oxygen. And if we plug this into our calculator, 51.4 divided by 15.99, I'm going to find that I have 3.2 moles of oxygen. And I'm going to do the exact same thing for carbon and hydrogen. So if I do that, if I take my mass of carbon, 42.12, and I divide by the molar mass of carbon, which is 12.01, I'm going to find that I have 3.5 moles of carbon. And then I'm going to do the same thing for hydrogen. So 6.48 grams of hydrogen divided by the molar mass of hydrogen, which is 1.01. And I have 6.4 moles of hydrogen. So now we just finished step 2. We've got our moles of hydrogen, we've got our moles of carbon, we've got our moles of oxygen. So step 2 is happy. Step 3, divide each element moles by the smallest number of moles I have. Looking at those 3 numbers I have, what am I going to divide by? I'm going to divide by 3.2 for each of them. I'm going to divide by 3.2 because 3.2 is my lowest number of moles that I have. So if I divide 3.2 by 3.2, what am I going to get? 1. Easy stuff. So if I divide 3.2 by 3.2, I'm going to get 1 oxygen. How can I show oxygen? 1 oxygen. I'm going to take 3.5 divided by 3.2. 3.5 divided by 3.2 is 1.09. And then I'm going to take 6.4 divided by 3.2. And I'm going to get 2. 2 hydrogens, 1.09 carbons. So step 3 is done. Step 4, make a whole number of moles by multiplication. Do I have all whole numbers right now? No. I have 1 oxygen, 1.09 carbon, and 2 hydrogens. What do I need to do to make 1.09 a whole number? Multiply by this one's going to be a big one. I'm going to multiply by 10. I'm going to multiply by 10. 1.09 times 10 is 11. It rounds up to 11. So if we multiply 1.09 times 10, we're going to get 11. If I do this, I got to do the same thing to everything. So I'll multiply 1 by 10. I get 10. And then if I multiply 2 by 10, I get 20. So 20 hydrogens, 11 carbons, and 10 oxygens. So step 4 is done. Now we just need to throw these guys into my formula. So using those numbers, those whole numbers I just found, 10, 11, and 20, I'm going to make my formula, my empirical or my molecular formula. So I'm going to have C, and I said I had C11. I have H20. All right, oh, not 11. And 10 oxygens. No. Usually you write carbon first, but we're not going to penalize you because we haven't taught you how to know how to organize that stuff. Yeah. So now we have our molecular formula, my empirical formula for this compound, C11H20O10. Can I figure out my molar mass now? You bet. I can figure out my molar mass. If I look at my periodic table, carbon is 12.01, and I have 11 carbons, so I'm going to multiply 12.01 by 11, plus my hydrogens, which is 1.01 times 20, plus my oxygens, which is 15.99 times 10. And I have my molar mass for C11H20O10 is 312.2 grams per mole. So you're going to add all these together. So you'll put a plus in between each one of these, and then you'll get your molar mass. So we're going to do some more practice ones. So that was the first time seeing this. I'm sure you're still a little bit confused. That's a lot of steps. That's a lot of steps. That's okay. Am I good to erase this? All right, we're going to do some more practice ones. We'll go through a couple as a group, and then I have a practice sheet for you. There we go. All right. So that's the math. So, definitions. The empirical formula is the simplest form of a compound, which means if I had C2, or that's CC, why did I have CC? C2, C2, H2, is that the simplest form of that compound? Can I simplify it? I can simplify this. This is not the simplest form. CH would be the simplest form. That would be our empirical formula. Simplest form. If all your subscripts are even, you can at least divide by 2 and get to your simplest form. When you're at your simplest form, you should at least have one odd number in your subscripts. Molecular formulas tell you how many atoms are making up each molecule. So molecular formulas are much more specific. They tell you exactly how many carbons you have, exactly how many oxygens you have. But empirical formulas are simplified. They're easier to write, but they're not as specific. So if I give you an empirical formula, you guys can find the EF is empirical formula's mass. You can plug in that molar mass into that spot. And we're going to use this equation in a second. And you can figure out what the molar mass of the molecular formula is. So make sure you write down this formula. Molecular mass divided by empirical formula mass equals N. And N is what you multiply each subscript by when you're trying to convert from empirical formula to molecular formula. Because empirical formulas are the simplified version. There are times you'll need to know the molecular formula. So you'll need to be able to find N to figure out what your molecular formula is. Any questions so far? We've got a couple practice problems here. We'll throw all these things together. We will connect the dots. That's the dream tape.
I have a dream.
So I have this question, and I'm going to write this up here for a second. All right. Pull it all together, guys. If the compound you find in the last slide is the empirical formula, so on the very first slide, we went through all the math to find the molar mass of our empirical formula is 312.2 grams per mole. Then what is the molecular formula if the molar mass of the compound is 624.6 grams per mole? Yeah. So yeah, we use that equation we just saw. So 624.6 grams per mole. That's our molecular formula. That's our MF. What has to go on the bottom, CJ? 312. That's our EF. If I do that, what am I going to get out? What's 624.6 divided by 312.2? It's 2. It's not quite 2, but it's pretty close. 2. 2 is our N. 2 is our N. Is our problem solved? Are we done? Did we do what the question asked us to do? What does it want us to find? We already found, it gives us the molar mass. We want to find what is the molecular formula. How do I do that using 2? Again. So, does anyone remember what our empirical formula for our first problem was? What was our empirical formula for our first problem? R was C11, H20, O10. That's my EF. What do I use this number for to convert my EF to my molecular formula MF? Multiply the subscripts. So I'm going to take 2, multiply all my subscripts by 2, and my MF is going to equal C22, H40, O20. That is my molecular formula. We multiplied everything by 2 because N was equal to 2. So I multiplied all my subscripts by 2 and found that my molecular formula was C22, H40, O20. People got this, or you want me to, is it okay if I erase it and we move on to the next slide? Yeah? Yeah? All right. So I have this new problem. We'll go through this problem together as another practice. I want you to tell me what I need to do. So I have this problem. The succinic acid is a substance produced by lichens. What are lichens? It's a moss algae symbiosis. They live together. They grow on trees, rocks, near water. Those lichens produce succinic acid. Chemical analysis indicates it is composed of 40.68% carbon, 5.08% hydrogen, and 54.24% oxygen. It has a molar mass of 118.1 grams per mole. Determine the empirical formula and the molecular formula. The empirical formula is going to be the simplest form.
I got 3.38.
It's a rounding thing.
Okay. So it's not gonna affect all that much? Is it a big deal? Then?
No, it won't. It won't affect you that much.
3.39 divided by 5.08, or would it be 5.08 divided
So
by
3.09 is your smallest number of moles.
Yeah.
So you're going to divide 5.08 by 3.09, and then you're going to divide 3.39 divided by 3.09, or 3.39, or whatever.
Yeah.
Yep.
Okay, I
Yep.
understand that part.
Yep.
Round that to 1.50 then.
Round it to 1.5. Yeah, I've got one up here. Yeah, try to round to the first decimal place if you can. Yeah.
You checked right away. What did that say? Did you look to see how much was in there? I just looked to see where it all was.
You could divide them all by 5, yeah.
Wait, what's this?
That's the molar mass that you found for C10H15O10. All right, so we're going to go through this one real quick. So all eyes on me. If you have questions, please stop me. So started with percentages, converted to grams. Once I have grams, I'm going to convert to moles. So I'm going to divide by the molar mass. So divide by 12.01. Divide by 1.01. Divide by 15.99. If you divide it by 1, if you divide it by 16, that's fine. That's okay. When you do that, you're going to get 40.68 divided by 12.01 is like 3.39 or 4. Who's got a calculator? 3.39 moles of carbon. 5.01 divided by, so it's like 5. How many moles of hydrogen do we have? 5.03 moles of hydrogen. And then we had 3.39 moles of oxygen. Everyone got those or close to it? Close? So now our next step is we have to divide by the lowest number of moles. Divide by the lowest number of moles. 39 is our lowest number, or 3.39. So I'm going to divide by 3, each one by 3.39. And when I do that, I get 1 carbon. What's 5.03 divided by 3.39? 1.48. To make it easy, I'm going to round 1.48 to 1.5. If it's ever close like that, round up. Make it easy on yourself. So 1.48, I'm going to round to 1.5 because that's going to make this a million times easier. And then I have 1 oxygen. So what am I going to multiply each of these by to make a whole number? I'm going to multiply by 2. Multiply by 2. Cheyenne? By 2, because we want to make everything a whole number. So right now we have carbon 1, H 1.5, and oxygen 1. Can we have 1.5 of a hydrogen, Cheyenne? Because we want to get to a whole number, so we want to multiply by 2. If we take 1.5 times 2, what do we get? It can change. It just depends on what. Make it easy on yourself. You do not have to multiply by 10. It could be by 2. It could be by 3. Whatever gets you to a whole number quicker. Cheyenne, it does not have to be multiplied by 10. So in this case, we're going to multiply by 2, giving us 2 carbons, 3 hydrogens, and 2 oxygens. Now I can just plug into my formula C2H3O2. This is my EF. This is my empirical formula, my simplified molecular formula. If you multiplied by 10, as long as you simplify this thing, you're going to get to the right answer. As long as you end up at whole numbers, you can simplify. You will get to C2H3O2, right? Because you guys did C10H15O, and you can simplify it to that. Okay? What's my molar mass of my empirical formula? It has a molar mass. Determine the empirical and molecular. So we have succinic acid is a substance produced by lichens. Chemical analysis indicates it's composed of 40.68% carbon. It has a molar mass of 118.1 grams per mole. Determine the empirical and molecular formula. So, last step. Guys, please, pull it back. Last step. We have our EF. I need to find my molecular formula. In order to do that, what do I have to find? I need to find N, right? N equals my MF divided by my EF. Mass and mass. Okay? So my problem gives me the molecular formula mass, 118.1 gram per mole. I just need to figure out what my molar mass for C2H3O2 is. So if I do that, I will find that my molar mass is going to be about 5 or 59 grams per mole. 118.1 is given to us. It's given it to us in our problem. The molar mass of my EF, C2H3O2, comes out to about 59 grams per mole. If you do the math, it comes about 59 grams per mole. Okay? If I divide 118 divided by 59, what am I going to get? 2. 2 is my N. 2 is this. It's my N. To find my molecular formula, I'm going to multiply all of my subscripts by 2. Okay? I'm going to multiply all my subscripts by 2. So my molecular formula ends up being C4H6O4. Yeah.